everyone. So, I welcome you all into this new series on machine learning and artificial intelligence. So, yeah, I've been exploring this field for like some time now, and I was a bit occupied with this, but I would love to share all these things. And there's a lot of fields. One of the very interesting fields that I like to explore is, you know, reinforcement learning, because it's very similar to how humans have evolved and learned. Like from the time of evolution until now, we have observed patterns in our environment and we have adopted to those changes to come up as the best species, in terms of the growth and all. Like we have been able to crack things through science and technology. We have observed patterns in nature and then we have used it to our advantages. Of course, it has some, everything comes with a cost and it has its own effects as well, but I don't want to go into that part. So this particular tutorial will talk about reinforcement learning, which is the core of reinforcement learning. You can say that it's Markov decision process. Not all the real world environments would be very deterministic, but somehow it's, this could be a base equation which helps us to relate. So as you can see in this diagram, we have an agent, which could be the robot or the algorithm that you're training on, which performs an action in the environment, and based on that its states gets updated. So for example, let's say maybe I'm reading something, maybe I am preparing for an exam, and my current state is I'm preparing, and let's say tomorrow I go and give my exams and then I qualify for something. So my state has now updated. It's very simple raw example. So state changes and then reward or penalty is being received with respect to whatever I do. Like that's, if you think of humans, that's how we also evolved. Like based on the good things, our mind triggered positive responses, and based on that we kept reinforcing it to basically push those things, and not push those things, in a way to bring those things up, and whichever was like not good, in a penalty way, we tried to avoid those. And that's how, from a normal proper animal species to a proper society and everything, it got developed. So anyways, so yeah, that's the core essence of reinforcement learning, Markov decision process. And in this one we are talking about multi-armed bandit. So multi-armed bandit is, those, you can say it's kind of a game and all that, things where you have levers and you trigger these responses, and based on that there is a chance that you may or may not win a lottery point. So this is one of the very common use cases, but I've chosen this example because we can relate it and connect it through different things. Like for now, we have a simple data set, which has age, gender, city, phone, operating system, etc. And this is like in my first organization where I worked, it was a digital marketing based agency, where our main aim was to enhance and increase the campaign performance based on different metrics like click-through rate, conversion rate, and all that. So here we will observe a pattern, like we will see how these parameters are affecting the click-through rate, and how a reinforcement learning agent would learn through multiple iterations. And for now we will consider, like, let's say gender as a metric, or we can select city also, but because we have lots of variation in city, maybe in phone also, iOS, Android, other is also there. So we can decide, like, okay, in this case, this particular data set that I would be using, it has genders, specifically male and female gender. So we will assume that 70% of the gender, when it is male, they'll be triggering this click, and 30%, I mean, this is just a very raw example. When we code, you will get to know more about it, but this is basically to demonstrate how the things will be working. So first we will create an environment. We will go through this Markov decision process to create an environment, and then we will see these 3-4 approaches. So one is random approach, another one is greedy approach, then we have epsilon greedy approach, and upper confidence bound. So random approach is very random, like you keep on exploring and then you keep on using the previous estimates to come up to the conclusion. Greedy is slightly different, like it will, like, let's say if I do 10 attempts, and if I
it's 20 hours.
Okay, yeah, this is one of my clocks, so I hope you don't get annoyed. It's just it keeps me reminding. Anyways, it just peaks every 15 minutes, so I hope that's fine. So yeah, this greedy approach is like it will, once it has explored all the types, like let's say we have 10 types of machines in this 1 2 3 4 5 6 7, okay, 7 machines. So once all the 7 machines are explored, then what we will do is we will focus on the one which is more promising. So that is what greedy approach is about. Epsilon is basically for the exploration. So I mean, it's good to exploit on, basically there's a equation of exploitation versus exploration. So let's say if I'm new to something, I will explore and first try to learn the rules based on the reward and feedback. I will explore and understand the system. Once I understand the system, then I will exploit what I already know to, you know, go to my best. And the same concept goes here also. So when we do greedy, we do only exploitation, meaning that, okay, we know that the second machine has given us the most amount of input. So we will always keep on pushing the lever for the second machine, okay? However, when we talk about epsilon greedy approach, what we do is we say, okay, we will exploit what we already know, but we will always give a scope for, you know, exploration. And that is defined by this epsilon coefficient that we will see. And then this upper confidence bound is similar to, you know, to basically map the exploration exploitation approach through a bonus term, which is a particular formula that I will get into this once I start to, you know, show you everything. Okay, so without any further delay, let's get started.